Hello everyone. Today I am going to discuss about the linked list. First of all, what is meant by linked list? A linked list is a linear data structure. What is meant by linear data structure? If we can organizing the data in the form of linear manner or a sequence manner is called as a linear data structure. And the linked list is a collection of nodes. A collection of nodes is also called as a linked list. A group of nodes will be form a linked list. Means here a node. What is meant by node means a node can be consisting the data field and link field. A node can consisting a data field and linked fields. And the nodes are created by using the structures. And this node can be representing the a data point and the pointer to the another of the next node addresses. And the usually the pointers also used for the using of the next node address, it will be stored. And what are the different types of linked list? Mainly we have the two types of linked list. One is a single linked list and double linked list. What is on the single linked list means? In a single linked list, the node, what is the node means? A collection of nodes. In a single linked list, a node can consist of two fields. That is, one field can be used for data field and another field can use it for the link field. Means in this data field we can store what is the exact data which you want to store, and the link field can be used for to store the address of the next node. That is the single linked list. Now what is meant by double linked list means? In double linked list, a node can consist of three fields. In this three field, the middle field is called as a data field, and the left side field called as a left link, and right side field called used for the R link. That means the data field, what is the data you want to store? The data will be stored into the data field. In left link, it can be used for to store the address of the previous node, and the R link can be used for to store the address of the next node. That means in double linked list we can perform the operation in the two ways, either in the forward direction or backward direction, whereas in single linked list there is only the forward direction we have to process. That is the two different types of linked list. And coming to first one, what is meant by single linked list? In single linked list, a node have the only one link part. That means this link part will be stored the address of the next node, and each link part contains the address of the next node in the list. How we have the number of list, each node will be having the address of the next node, and the last node of link is always null, and also it will be signifies the end of the particular linked list. If there is a n number of nodes, we have this is a node 1, suppose node 2 and node 3. Here is the n number of nodes. In this n number of nodes, here it will be stored, suppose address of this node, here it will be stored, and this node address will be stored on here, and this node address is always as a null. If there is no any next node, means the address of the last node is link is always represented as a null node. And this is the graphical representation of the single linked list. Here we can see, here I can creating the four nodes, means there is the four nodes here. Now it will be represent the first node in the linked list, and it is the last node of the linked list. Here the first node linked list, the initial address will be stored into the header node. Now this node is also called as a header node. This header node will be hold the initial node address, and here you have to store this node address will be stored on here, and here you have to store the this node address. Here B, A, B, C, D are all called the data which you want to store in your database or data structure, and the last node link, there is no any node means we have to assign the value as a null, and each node contains the value of the data and pointer to the next node of the list. and the my list or head node will be consisting the header point which points at the first node of the list. Based on the first header file, what is the first node you have to have. This is the semantic representation of the single linked list. And what are the basic operations we have to performing in the single linked list? Here mainly you have to create the n number of list and inserting the element into the particular list and delete the element from the list and search for the particular data value from the linked list and reversing of the linked list. And here we have to performing creating means you can creating the n number of nodes to form the linked list. Whenever you have to create it in this already existing list, here if you want to perform the insertion, what is meant by insertion means you can inserting the new node into a already existing node. Suppose here we can perform the insertion operation in three ways. That means we can insert the node at beginning of the linked list. What is the linked list we have to create it? At the beginning of the linked list we have to create the node and we have to insert the node at end of the linked list. We can create end of the linked list and we have to insert the node at any position. In which position, or we have to select the in particular position. At any position we have to insert. That is the same. Means we can insert the node into a already existing list. We can inserting in the three ways: at beginning of the linked list, or end of the linked list, or at any position. The same way, if you want to perform the deletion operation, same way we can delete the node from the linked list. That node may be a beginning of the node, or end node, last node, or at any position. In which position you want to delete. That means you can perform the either insertion operation or deletion operation in the three ways. That means at the beginning of the node, or end of the node, or at any positions. And first one, the first operation is the creation operation. Means we can create the node. How we can create? Before creating the node, you have to represent structure of the node. It is a single linked list. Structure is nothing but a node can consist of two fields. One field is called as the data field, that which you want to store. That is the representing of the data field. And what is the next field? The next field is a link field. This link field can be used for to store the address of the next node. What is the node you have to having the successive nodes? It is a syntax for to creation of the single node you have to creating. And if you can call this function for whenever you want to creating the dynamic operations, it will be creating the n number of nodes. And see, it is the logic. Whenever I have to create the node, in this node I have to store the some value. What is the value I want to store? Here I can create the node. Here I can passing the argument, some argument as a particular node creation, and I can creating the one pointer. That is the pointer is the new node I have to create it. For this pointer I can using the memory allocation by using the keyword as a new. It is the dynamic memory allocations. And if the pointer equal to null means we can say there is no node will be created. Otherwise, what is the node you have to create it? The node name is a pointer. It is a pointer node. This pointer node of data field. The pointer node of data field. That is the this is the field. In this one I have to assign the num value. What is the num value you have passing? I can passing the num value as a 1. And that will be stored in the here. And the pointer of next, that means the in this link field initially I have to assign the value as a null. That means there is no next node. That's why initially I have to assigning the value as a null. Suppose here again I can creating the one more node. Suppose I can call the same operation here. That time here the pointer value is initially null. If it is a false means now pointer value, suppose for example this address location is 1000. Suppose the address location is 1000 for the first node. Now again calls the same operation. Here I can creating the one more node here. Suppose it is the new node we have to create it. This is the new node. This is the new node I have to create it. Suppose the node address is 2000. Right? Now in this node I have to assign the some value. That value as a 2 that I have to read. As I can starting the pass value as a 2, that value is passing. Now the pointer value is the 1000. It is not be null. If it is a If it is not equal to null means here I can say that is the else part. In else part I can write the some logic. How we can form link between these two nodes. Suppose the name of the node, it is a first node in my linked list, as well as it is the last node also in my linked list, when if I have the single node. Now whenever I can creating one more node, then I want to form link between these two nodes, as well as I have to change the position of my last node also. Why? Because if I have the two node means the second node is the last node. Then what is the change will be required? Then I can write the logic as a last of link. What is the last node? Suppose this one. Then last of link or next is, okay, last of link is nothing but what is the value I have to assign? What is the new node I have to create? The new node which I have to create, that is the last node. And as well, then automatically the link will be formed. That means the 2000 address will be stored on in this position. The address of 2000 will be stored on here, right? Then automatically I have to store the value as a 2. Then this node link value is the null. And if I have the two nodes means now which one is the last node? What is the newly create node? This is the last node. Now here I have to change the position of last node also. I have to change the position of last node also here. That means I can write the logic last equal to what is the new node which I have to create. Okay. It is a logic for to create the n number of nodes. After creation of this n number of nodes, then we have to performing the insertion operation. Here you can performing the insertion operation the three ways. That is the in a already existing linked list we can perform the insertion operation. How many ways you can perform the insertion operation means three ways. That means we can insert a node at beginning of the linked list, or at end of the linked list, or at any particular node. If there is a n number of nodes here, suppose it is a node 1, suppose it is the node 2, suppose it is the node 3, and it is the node 4. Now it is already existing linked list. Now in this existing linked list, now I want to insert the new node, or beginning of the new node I have to insert. Suppose it is a new node I want to insert. Now it is already name of the node is a first node. Suppose it is a first node and it is the last node, right? Now if I want to insert the node of position here means I want to form link between these two nodes. How I can change? Suppose it is a new node means then I have to change the new node of link equal to first. What is the first address? That address will be stored into the here, and I can change automatically. What is the first node? Now first node is nothing but what is the new node I have to create. Then automatically change the position of the node. That is the insertion beginning at new node. And at last means you have to identify what is the last node. Means how you can identify the last node? Always the last node link is represent the null. If the last node link is null means then you have to assume it is the last node. Then automatically you have changed the last of link is also new node which you have to created, and change the position of last node is equal to new node which you have to created. And at any position, suppose I want to insert in between these two nodes, I have to creating the new node. Then we have to form link within these two node and then here. Then before that we have to identify what is the previous node, what is the current node. In between previous and current node you have to insert the new node which you want to insert, right? It is the logic for to insert the node at beginning, at end, at any particular position. And these are the some steps to involve into insert at the beginning. Means make the next pointer of the node point towards the first node of the linked list, right? And make the start pointer point towards the this new node. What is the new node you have to create it? That will be going to the starting point. That means we have to assign the address into the header node. If the list is a empty simply, then you make the start pointer as the towards the points which you have to creating the new node. Suppose that is the new node which you have to create it. That is the only one node. Then you can make it as a starting node, as a pointing node. That is the existing node means you have to change the positions. See here. Initially there is no node, it's the new node we have to create it, right? Now here initially they have to be having the n number of nodes here. Initially the address of this initial address will be stored into the header node. Whenever I can creating the new node here, this node will be again pointing to the header node, and the address of this node will be assigning to the here. Suppose the name of the node here, it is a first, right? Then what are the changes will be required? Suppose this node is the new node. Now new of link equal to first, or first is also called as a head. What is the head value? Head value is the address of this node. Okay, after that you can change it. What is the head equal to? What is the new node you have to create it? This is the new node you have to create it. Then automatically the link will be formed between these two nodes. It is a logic for to insert the node at beginning of the linked list. Right? See, it's a simple statements. You have to see, check either the starting node is a null or not. If it is a null, you have to create the starting node as a first node. Otherwise, we can change the temp equal to the starting node, and then you can start the what is the starting node you have to create at the first node as a pointer, and we can change the position of the pointing node. And inserting the node at end. Same way, you have to inserting. It is already existing node. Always the last node link is the null. Now it is a new node. The link of means the last of link. You have to assign the new node which you have to create. You have to creating the node here. Then you automatically change the position of last node also. That means the last equal to what is the new node we have to create. And it is a logic for to inserting the new node. And inserting the after an element means there is a number of nodes. In this n number of nodes you want to insert at middle of the node. That means it is already one node, here is one node. In between I have to inserting the one new node. How we can insert? Before inserting the node you have to identify what is the previous node, what is the current node. In between I have to inserting the new node. That means previous node of link equal to new node as well as the new node of link equal to current node. In between I have to inserting the node. It is the logic for to performing the insertion in three ways. Same way we can perform deletion in the double linked list also. You can delete the node at first node as well as last node and at intermediate node or at any position node which node you want to delete. Then how we can delete the node? Means you can delete the node means you can remove or you can free the memory space which is already allocated by using the new node or a malloc. Here we can delete the new node here. This is the first node I have to create it. Now I want to delete. Means the start node is not also called as a header node. Means the header node will be hold the address of the first node. Now this first node of the link is available in the second node address. Then I can assign that is a start equal to first node of link or start of link. The start value is 1000. The 1000 of link is what is the node? This one. That is automatically I can change the position of start node, and I have to free. What is the node? I have temporarily assigned as a free node or temp node. The temp node will be deleted. That is the logic for to delete the node at starting. See, initially I can creating the temp node. For temp node I have to assign the starting value. And then can change what is the starting next automatically. Start equal to temp of link. Suppose temp value is 1000. 1000 of link means suppose second node is a 2000. That node will be assigned. And then you can delete or free the particular temp node. And delete the last node. Here you have to apply the two steps. Means first you can make the second last node. That is the second pointer. And whenever the last node of link is the null. Then you have to identify. Then before that what is the previous node you have to identify. The current node is the deletion node. Now we have to change what is the last node. The last equal to previous of link. And delete the particular node in your linked list. Then we have to identify. Now here also same we have to identify what is the previous node and what is the current node. The current node is the delete node. Then we can change. We can form the link. That means the previous of link is equal to the current of the link. Then automatically form link between these two nodes. Maybe because this node can consist of address of this node. Here you have to form. Then you can write this logic means we can delete the node at any particular position. Is the logic for to delete the node at any